Law of Conservation of Energy. In this conceptual lecture, you will learn the most easy way to remember the law of conservation of energy. Therefore, do not skip any point and watch the lecture till the end. What is energy? Energy is the ability to do some sort of work. For example, the car has kinetic energy while moving from one place to another. If you want to learn the complete concept of energy, then there is a separate lecture on energy, and the link will be given in the description. As we know that we have different forms of energy, one can ask this question that why we have various or several forms of energy, or why energy doesn't exist in only one form. Well, the answer is very simple. We do different works or different bodies perform different sort of works. For example, if you raise an object above the Earth's surface, it possesses potential energy at a particular height above the ground. When you release this object and it falls down, its potential energy is gradually converted into kinetic energy. And when it hits the ground, its kinetic energy is converted into heat and sound energy. Thus, a body in a specific conditions or in a specific location or state possesses a specific sort of energy. Therefore, energy gets a particular form at a particular state. For example, when the body was above the ground, it possessed potential energy. When the body was falling, its potential energy changed into kinetic energy. And when it hits the ground, its kinetic energy changed into sound energy and heat energy. So from this example, we also learn that energy changes from one form to another form. Now to learn and understand this form changing phenomena of energy, scientists put forward the law of conservation of energy. Law of conservation of energy. It states three important points. Energy can neither be created nor destroyed. Energy changes different forms. Energy in a system remains constant. To elaborate these points, let's consider that you have a bottle of petrol. We know that petrol possesses chemical energy. Let this bottle of petrol have 10 joule of chemical energy. Now you put this 10 joule of petrol into the car's tanky. The car will use this 10 joule of chemical energy in order to produce 10 joule of kinetic energy in the form of motion. Thus we completely transfer 10 joule of chemical energy into 10 joule of kinetic energy without destruction or any wastage. Remember that law of conservation of energy is an ideal case. Now let me prove mathematically that law of conservation is 100% authentic and it exists. For example, if a ball of mass m is present at a point A at a height of h from the surface of a ground, I am interested to find the energy of the ball at point A, B and C. Let the height of A and B is h1. H minus h1. We know that the ball is present above the Earth's surface, which possesses potential energy. Now, as it is falling downward, its potential energy will be gradually changing into kinetic energy. So in this example or in this system, we have to encounter two forms of energy. I mean potential energy and kinetic energy. Therefore, according to the law of conservation of energy, the total energy of the system remains constant. Or you can say that here in this system, the total energy is the sum of kinetic energy and potential energy. Now at point A, the total energy of the system is kinetic energy plus potential energy. Here at A, the ball is at rest. hence its kinetic energy is 0, while the potential energy of the ball is mgh. Hence total energy of the ball at point A is mgh. Now I want to find out the total energy of the system at point B, as the ball will be falling down when it reaches point B. It means ball will possesses velocity v at B, or the velocity of ball at B is equal to v. According to third equation of motion, v square is equal to u square plus 2gh. Here the ball has travelled this distance, or h1. Hence instead of h we will put h1, and we will get v square is equal to u square plus 2gh1. U is the initial velocity of the ball. The ball is at rest initially. Hence its initial velocity, or u, is equal to 0 meter per second. Therefore v square is equal to gh. We know that kinetic energy is equal to 1 by 2 mv square. Now putting the values of v square in this equation, kinetic energy is equal to mgh1. Now what about potential energy at B? At B, the ball is present at height of h minus h1. Hence its potential energy is equal to mgh h minus h1. Or potential energy is equal to mgh minus mgh1. We know that total energy of the ball is equal to kinetic energy plus potential energy at point B. Hence kinetic energy is equal to mgh1 and potential energy is equal to mgh minus mgh1. Therefore total energy is equal to mgh1 plus mgh minus mgh1. Hence this and this is cancelled out. We get total energy is equal to mgh. Thus the total energy of the ball at point B is also mgh. Now let me find the total energy at point C. As we know that the ball will hit the ground as it reaches the point C. Hence the potential energy of the ball at point C would be 0. So potential energy is equal to 0. Now what about kinetic energy? We know that when the ball reaches point C, its velocity will be v, or the velocity of a ball at C is equal to v. Now according to third equation of motion, v square is equal to u square plus 2gh. Again the initial velocity u is equal to 0 meter per second. Hence v square is equal to 2gh. We know that kinetic energy is equal to 1 by 2 mv square. Now put the value of v and kinetic energy. Thus kinetic energy is equal to 1 by 2 m 2gh. Hence kinetic energy is equal to mgh. Now total energy at point C is equal to kinetic energy plus potential energy. Hence total energy is equal to mgh plus 0. Our total energy is equal to mgh. Hence total energy at point C is mgh. Thus total energy at A is mgh, while total energy at B is mgh, and total energy at C is also mgh. Thus total energy of the ball at each and every point is mgh. Or we can say the total energy of the ball is conserved. I hope you have learned the concept of law of conservation of energy. Thank you very much for watching this video.
Application of the law of conservation of energy to a simple pendulum. In our earlier session, we have learnt about law of conservation of energy. Now, let us learn how law of conservation of energy is applied. Let us explain it by using a simple pendulum. Activity. Let's take a simple pendulum and suspend it from a stand. The normal position of the simple pendulum is noted as OA. Now, pull the bob of the pendulum at one extreme position B and release it. It reaches to the other extreme position C and goes on. If the bob goes from B to C and come back to B and so on, it is called as one oscillation. When the bob is at extreme positions B and C, its velocity of the bob is zero, so its kinetic energy, Ke, is zero. When the bob is above normal height, h, that is, when it is at extreme points, it has potential energy, Pe, so its Ke is zero. But when the bob leaves the extreme position and crosses its mean position, its height, h, is zero. Then its Pe is also zero and has kinetic energy. At equilibrium position, it has kinetic energy and potential energy is zero. And at extreme position, it has potential energy and kinetic energy is zero. In between equilibrium and extreme position, it has both potential and kinetic energy. Other than the equilibrium and extreme positions, any point in the oscillation has total energy sum of Pe and Ke. The sum of Pe and Ke always remains constant. Thus, from the above experiment, we can find the energy is transformed from potential energy to kinetic energy and from kinetic energy to potential energy. But it is neither created nor destroyed. This is called as law of conservation of energy.